6 meters away, all equals to 0. Solving for Cx, we get our solution as 45 kilonewton. Cx, which is positive 45, and then we have negative 90 kilonewton and a positive dx, all equals to 0. And we get a solution for dx as 45 kilonewton as well. Alright, now that we have required reaction forces at this point, now we can proceed over to our next section, which is BC. For BC, we have opposite reaction forces. So whatever we had earlier, we can have opposite reaction forces at pin connection C. So CY we have found to be, before we do our member BC, we still have to find our forces for CY and DY. However, we can't really solve for these because the influence at pin and D, at pin C and D is going to come from member BC. So first we have to solve for those before we could solve for our CY and CX. So we're going to hold on those two members or reaction forces for now, and we're going to continue at our member B, where we have horizontal and vertical force, plus we're going to have moment at B, and then we have 2-point loads. One is 40 kilonewton and the other is 50 kilonewton. Distance between the two force vectors is 2 meters and 1.5 meters on each side. Alright, so now that we are here, we can start solving for member BX, another solution, and then we can sum the forces in y direction, and we're going to have positive By, negative 40 and negative 50, which is 90 kilonewton, and then we have positive Cy equals to 0. We have to hold this equation right here for now, so we're going to name it equation 1, and then we can take moment about the point B. So we're going to have moment B, we have clockwise 40 kilonewton, 3.5 meters away, and finally we have counterclockwise Cy. We're going to hold this equation here as well, and we'll name it equation 2 for now. Let's move on to our next part, which is going to be our member AB. Pin connection at A. Opposite reaction forces. Bx is known already, which is 45. And solving for forces in x direction, we're gonna know or find out that our Ax is 45 kilonewton as well. And now we can take a moment about the point A to find our solution for moment B. So we're going to have negative moment B, and then we have counterclockwise Bx, and it's 180 kilonewton meter. And now we can plug the value of the moment B in our equation 2. So we're going to have 180 kilonewton meter and solve for Cy. And solving for Cy, we get our solution as 7 kilonewton. Now we can use this value of Cy to find our solution for By by plugging the value of Cy into equation 1. So we're going to have By take away 90 kilonewton plus 7 kilonewton equals to 0. Solving for By, we'll have our solution as 83 kilonewton. And now, using the value of the By, we can find our solution for Ay, which is going to be positive Ay, negative By equals to 0. And solving for Ay, we're going to have our solution as 83 kilonewton, positive, or you can say upwards. Alright, so now that we have that, we can go back a point further back. We have Cy here, which we had as 7 kilonewton. And now, by summing the forces in y direction, we can find the value of the dy. And dy is negative 7 kilonewton equals to 0, and dy is going to be 7 kilonewton as well. And with that, we have solved for all direction forces. Now we're going to start plotting our diagrams for each of the graphs. So we'll start with AB. So our AB is a little tricky because it's upside down. And this means, well, pretty much we're going to take a value of the AX instead of the usual Y for shear. So in this case, AX is going downwards, so we're going to begin at negative 45 kilonewton, and then nothing's going to happen for the next 4 meters. And then we have BX, which is going upward 45, and we come down to 0. So this is our AY, pardon me, AB. Then comes our next section, which is BC. So in BC, our BY is 83 kilonewton, and then from 83, nothing's going to happen for 1.5 meters. So I'm going to assume this is 1.5 meters. 33. So let's say 33 is around here. It's not to scale. I can write it down here just so that nobody confuses. Okay, and from there we go another 40 down, and we come down to negative 7. So first we're gonna run for 1.5 meters, pardon me, 2 meters, and then come down 40, which will take us to negative 7. For our CD section, our dx is going downwards, so this means we're going to go down, pardon me, it's going upwards, not downwards. And actually, I'm going to start from this side because this is the logical side, but it doesn't really matter which side we start from because ultimately our shear should be 0. So our CX, which took us upwards earlier, it's going to take us another upwards. So earlier we took a 7 kilonewton pump, but that was our CY, and now CX is pushing us up to 45 kilonewton. And from there, because it's a distributed load of 0-degree curve, over the is gonna push us up again, and dx was 45 kilonewton, and that comes down to 0. Now we can proceed to our moment diagram. Similar idea as before, and we're gonna try to use graphical method. So this area is going to be negative, so we have 45 times 4, so we're gonna go down using the first order curve down all the way to 180, and then we have moment P clockwise, which is going to push us up 180, bring us to 0. This means our AB section is correct. And then we have this section, which is positive. So it's 83 times 1.5 meters, which will be, we are going upwards. We're going to go upwards of 124.5. So I'm going to say 124 is around about here. And then we have this area, which is 33 times 2, and this is 66, 124.5. Oh, and one thing we missed, but we have to redo this part a little bit. We forgot about the initial moment, which will bring us back to 180. So we are here right now, and then we have 124.5. So 180 plus 140.5 will take us to negative 55.5 and first order curve. And then we have the other section, which is 33 times 2, which is 55 plus 66 will take us to positive 10.5 first order curve. And then we have this tiny area, which is negative, and it's 1.5. So negative 7 times 1.5 is negative 10.5, and this will bring us to back to 0. And that's our BC area. Now we're left with the remaining portion, which is our CD. And because we have symmetrical or symmetrical uniform distributed load over the 6 meters, we know that our intersection, which occurred here, is going to be at 3 meters from the 0 mark. With respect to member CD, we can calculate these areas. So this means our maximum is going to be around here somewhere. We're going to come down both ways and it'll be 0. Anyway, so 45 times 3 is 135. So our peak